In section 5.10, we're going to be talking about improper integrals. The first type is type 1, which is infinite intervals. If we'd like to take a look at this figure here, we have an area under here. We're going to consider the infinite region S that lies under the curve y equals 1 over x squared, which is above the x-axis and to the right of the vertical line x is equal to 1. You might think that since S is infinite in extent, its area must be infinite. But let's take a closer look. So the area of the part of S that lies to the left of the line, x equals t, is what's shaded. Now, if we look at this as an integral, we would have the area of a function of t that's going from the value of 1 to t of 1 over x squared dx. We take the antiderivative of that, we get negative 1 over x, going from the lower limit of 1 to t, which is equal to 1 minus 1 over t. Now, if you notice that the area, that function, is less than 1, no matter how large t is chosen, because you're always subtracting this amount from 1. And we also observe that the limit, as the value of t is approaching infinity of that function, is equal to the limit as t is approaching infinity of that solution, which is 1 minus 1 over t. 1 over infinity is 0, so 1 minus 0 is going to give you the value of 1. Now, the area of the shaded region approaches 1 as the value of t is approaching infinity. So we say that the area of the infinite region S is equal to 1, and then we would write the following. So here we would have this integral that goes from a lower limit of 1 to infinity of 1 over x squared dx is then equal to the limit as t approaches infinity from 1 to t, 1 over x squared dx, which is equal to 1. Now, you can see here what's happening with each one of these particular scenarios here. Here, if we go from a lower limit of 1 to 2, the area is equal to 1/2. If we go to 1 to 3 and we're looking at that area, now it becomes 2/3. Going from 1 to 5, the area becomes 4/5. Going from 1, and it continues and continues, I can see here that the area is becoming 1. So each area, you can see how this small area gets bigger here, ultimately to the area of 1. So it's increasing to the area of 1. Now, using this example as a guide, we define the integral of f, not necessarily a positive function, over an infinite interval as the limit of integrals over finite intervals.